So, like I was saying, if you look at let's look at this. If you draw the Newman projection, you have a metal pointing down. Looking at it from this bond, you have an OCH3, and you have a BR here. Then this back carbon, if you're looking at the longest carbon, you're going to see this hydrogen on the side, and you're going to see the methyl on the side, on the left. You're going to see it pointing up like this. See, but it cannot happen like this. It cannot happen like this. So what you need to do is you need to rotate. See, because this have to be anti-peripheral. So if you rotate it, then what happens? It becomes. So you leave the back carbon steady, and you rotate the front carbon. So this BR is not going to be pointing here like this. Then this is going to OH3, it's going to be pointing down like that. The CH3 is going to be pointing out like that. So you can see that the two groups that need to be eliminated are going to be anti-peripheral. So once you get rid of those two groups, what you're going to have will be this. You're going to have a CH3. Then you're going to have an OCH3 and a CH3. See, so if you translate it, it becomes if you look at it, the methyl groups so you're going to have OCH3 you're going to have a CH3 here and an OCH3. On that same side, you're going to have the CH3, and then you're going to have this, like that. So you can see, if you look at the stereochemistry, you can see that this is going to be 1, this is 2, and this is 1, and this is 2. So you're going to have it to be E. And so if you look at this one here, you see this is 1, and this is 2, this is 1, and this is 2, and that is E. And so the answer is C. Now, again, you have to remember when you're doing E2 mechanisms, this is going to be an E2 because it's a strong base. Now, don't forget, you have a hydrogen here. Sorry. You have a hydrogen here. And you have a hydrogen here. This hydrogen is preferred. This hydrogen is preferred. Why? Because these two are anti-peripheral. You're going to have it like this. So double bond like that. And that's why it's going to be A. Now, this is going to be go E1. So it's going to go via a carbocation. So upon loss of this, we're going to have this. A positive charge here. And this can lead to this plus this, like that. See, because this rotation about this bond. Now you can also have a hydride shift, in which case this can migrate. See, this, one of these bonds can migrate over here. You get this hydride shift, and that would lead to the following products. This will be done. So you can have as well as see. So you're going to have a total of 4 products. You're going to have this, you're going to have this, you're going to have this, have that. So you're going to have a total of 4 products. Now this is going to go via E1. The once this is protonated, you break this. What's going to happen is you're going to have the formation then you have a hydride shift, so your answer is going to be C. So you're going to have a 1, 2 hydride shift, because you can imagine that this methyl can migrate like that. So that's why your answer will be C. Now, to be able to determine the following, which of the following starting materials could not be used to produce the following alkene, you have to consider the different carbocations that will form, say, after they have the loss of the hydroxide. So if you make this percentage like that, make this percentage like that, percentage like that, like that, you can have the loss of like this, like that, like that, like that. Have a positive charge there. It's going to lead to have the formation of See, we can have see, right, how this one can lead to that, like that. See? So let's look at all the carbocations to be able to decide which ones can lead to the product as stated. This is a possibility, because if this were to migrate, if this methyl group were to migrate, then you can get to this, right? And this will give you this. This will also give you this, right? But if you look at this, nothing can happen here. If you were to take this hydrogen and migrate it over here, what do you get? What you get will not be anywhere close to, the product. What you're going to get will be this. See? This will no way give you this. So it's not possible. So this one cannot be used. See, this one cannot be used. So let me cross that out. So 4 cannot be used. So which of the following correct represent an E1 reaction? In the E1 reaction, you have the loss of leaving group followed by the proton transfer. See, so here you have a loss of leaving group, and then you have a proton transfer. You have 1 and 2 happening. Loss of leaving group and the proton transfer. But this doesn't occur here. This is all wrong. You can have this. You can have it. It's not concerted. And this is not concerted. The E1 is stepwise. See? And of course this is wrong as well. So you can see that the right. So if you look at the reason why it's A, you see, you have a loss of leaving group, and through the proton transfer. You can see there's a wrong arrow position here. A strong base will give you E2, and a wrong proton transfer. It's a wrong proton you're picking here. Okay, so that's why the answer is not like that. So the answer is A.